we're looking to be able to expand and condense logarithms using three main properties. And the goal or reason we are doing this is so that way we can then work on solving equations. So you have three main properties of logarithms. Right. So your properties of logarithms is first that if you have the log of a base and you have multiple factors, values or letters, variables that are being multiplied together, that your rule is that the log of the same base of the first factor can be added to the log of the same base of the other factor. And so what this does is it allows us to work towards the right-hand side, which means we are expanding. And if we take something that looks like this, we can move to the left and condense. So some key issues is that when you break apart your separate factors, they each need to have the log of the same base, and that you are adding those two terms. Likewise, if you're going backwards, if you see something like this that's being added, you're not adding. Going backwards means you have to multiply. And there's some reasons for that and some properties that we will get into later. But for example, I'll show you how this is going to work. Right. So for example, say we have log base 4 of 3x. All right, so you can see we have two different factors, a 3 and an x. And so I'm going to split this up as log base 4 of 3 plus log base 4 of x. And so my individual factors are written out with the same logarithm. Your second property is what happens when you have the quotient of multiple factors. Now when you have the quotient of multiple factors, again, the first factor or the factor in the numerator gets the log, but now this division symbol is going to change when we expand to be a subtraction sign. And again, moving towards the right means you are expanding, you're making more terms. Taking something from the right and moving to the left means you are condensing. All right? But when you see two terms with the same log subtracted from each other, that means that I can condense to a quotient. And again, let's look at this. So log base b of x plus 1 divided by 5. Right? So again, the log does not have to be a number. It can be a variable as well. So that's the same as log base b of the numerator minus log base b of the denominator. All right, so it's very important that you see that the entire numerator must stay together. All right, you cannot split up logarithms that are currently with an addition sign in there. So there's no way to further expand a binomial. It must stay together as the entire numerator. All right, and so we need to make sure we put that in parentheses so that way we know that's the numerator. Because again, if we go backwards and we see that we have two different terms, both with the same log, I want to be able to know that this whole part is going to need to go into the numerator, and this is going to go in the denominator when we condense. And our third rule, log base a of the mn, meaning now that we have an exponent, means that whatever the exponent is goes out front as a multiplicative factor, and then we have log base a of the factor. All right, and so again, this is going to help us go backwards. If we see a number being multiplied in front of the log of a certain base, that can be written as the exponent to that value. So again, let's look at one. So log base 3 of the 2x plus 1 cubed. Now again, this whole 2x plus 1 is considered my base. All right, so this is all is considered my base, which is like my m right here. All right, and so I can't do anything. I can't break apart the 2x plus 1. All I can do is say this exponent is going to come out front, and then I'm going to have the log of that base of the value, or that factor. So make sure that you put those in parentheses. Now there's some other ones. These are logarithms, but then we also have ones dealing with ln that are the exact same. It's just you're able to use log base e. And so what I wanted to show you is how those are the exact same properties. So if you see ln and you put two factors next to each other, this is just the natural log, but the property still is the same. It's the ln of the first plus the ln of the second. Right. Again, you can do the same thing with the middle term. Ln of a quotient is the ln of the first minus the ln of the second factor. And then you also have your power rule. So again, multiplicative factor times the ln of the value. And so you can see some examples of these as well. Again, if I take the ln and maybe I have two binomials being multiplied together, the x plus 1 is considered my m, like over here, and the x minus 5 is my n. You do not want to multiply this out. If you multiply it out, there's no way to use a rule to continue to expand. So you need to leave these as a factor and another factor and rewrite it as the ln of the first factor plus the ln of the second factor. That's all you can do. Okay. Likewise, if I have the ln of x divided by 2, all right, so now I have a quotient. So that's the ln of x minus the ln of 2. So you notice that the properties with the natural logs are the same as the properties of just regular logarithms. And again, if I have the ln of 7 cubed, that's the same thing as 3 times the ln of 7. So you want to be able to understand how to expand and condense these properties. And we're going to do a few weird ones as well.